Welcome in .core. Scientists have achieved quantum teleportation. And you're probably thinking that in the future you can find yourself on a beach in the Maldives in half a second, getting there right from a snowy village in Finland. Just imagine how much money you'll save on air tickets. But stop. Don't go that far. Scientists have only managed to transfer a piece of quantum information from one quantum computer to another. The distance between them was 6.5 feet, but that piece of information moved as if there was no distance at all. It isn't easy to understand what happened there. To do this, we'll use the most powerful computer in the universe, your brain. So, scientists at Oxford have learned how to teleport quantum information. Ordinary information consists of bits, while quantum information consists of qubits. And there's a difference. Imagine a small switch. When it's off, it means 0. When it's on, it means 1. And an ordinary computer works with this information. Qubits represent both 0 and 1 at the same time. That is until you look at the switch. You don't know if it's on or not. This means that it's in a superposition. And only when you look at it does it take position 1 or 0. So a quantum computer works with qubits that show superposition. Until you measure a qubit, it's in all positions at once. But after measuring it, it shows 0 or 1. This unique feature allows quantum computers to perform several tasks simultaneously. In the quantum world, if you take an exam, you don't write one task after another. You write all the tasks at the same time. This is the first thing to remember to understand quantum teleportation. The second thing is entanglement. Scientists take two particles and entangle them together. This means that they are now connected. If a certain action occurs with one particle, then the same action occurs instantly with the other. Imagine that you have two pens. One is blue, the other is red. You put each pen in a separate box. You don't know which box has red or blue pens because you can't see them under the closed lid. The pen in one of the boxes can be both red and blue, like Schrodinger's cat. Next, you pick up one box and take it to the Amazon jungle. You also send the second box to the top of Mount Everest. As soon as you open the box in the jungle and see the blue pen, it immediately becomes clear that the pen on Mount Everest is red. That's what happens to entangled particles. For example, if one of the particles at one end of the galaxy turns red, the twin particle at the other end of the galaxy instantly reacts to this and turns blue as if there was no distance at all. These twin particles sense each other and react instantly. This transfer of a quantum state from one particle to another is quantum teleportation. But scientists have known about this for a long time. What new things have they discovered now? They use quantum teleportation to operate a supercomputer. Ordinary computers use cables, wireless Wi-Fi, and a local area network to communicate with one another. All these things ensure that information is transferred from one computer to another at a very fast speed. But it's not teleportation. Each transmitted bit of information has a speed at which it moves. But now, thanks to this quantum stuff, scientists can teleport this information instead of transmitting it. Right now, quantum computers are very fragile and heavy any awkward movement, and they can break. But with the help of quantum teleportation, they can be combined into one powerful supercomputer even if its parts are at a distance from one another. So far, this distance has been 6.5 feet, but scientists continue to experiment. Okay, we've got it. Two particles react to each other as if distance doesn't exist. But what exactly is teleported in a computer? It seems we need to strain our brains a little more. So the particle is in a superposition. That is, it can be in all states at the same time until you look at it. Like that box with a pen on Everest. And here's what the scientists did. Imagine that you have a particle of light, photon A. This is a photon you want to teleport. You also have photons B and C which are already entangled. Photon B is located on the first computer. Photon C is located on the second computer. You remember that photons react to each other. That is, if you measure and look at one photon, the second one will immediately feel it and take the appropriate shape. You're not looking at them right now. Just remember this fact. Then you take photons A and B and make them interact with each other. You measure this interaction using a special device. After that, you look at photon A and it loses its superposition. The magical property of the particle disappears. Then you send information about the interaction of photons A and B to another computer. Photon C reads this information and takes the form of photon A. The original photon A disappears and photon C becomes photon A. Okay, but how do scientists make particles entangle? And what does it mean to make photon A interact with photon B? They use special crystals and complex technology to make particles entangled. Complicated scientific things are also used to create the interaction between photons A and B. But let's not overload our brains with these things. Time to take stock. Here's a quick retelling of what happened. Photon A is the one we want to teleport. Photons B and C are entangled in advance. They're like twins. A and B interact with each other. We read A. This information is transmitted to C. C becomes a copy of A and A disappears. In 2002, scientists managed to teleport a laser beam this way. In 2006, they teleported information from a laser into a cloud of atoms. Don't ask. It already sounds very difficult. In 2012, they teleported a photon from one end of the city to the other. And now, scientists have been able to teleport the quantum state of a qubit between two computers. If this technology develops further, scientists will be able to replace parts in computers without disassembling them. For example, you have something broken in the processor inside a quantum computer. You don't need to dismantle the entire computer, remove the processor, and put a new one in there and put the pieces back together. Thanks to quantum teleportation, the processor can be replaced instantly inside the computer. Okay, this all sounds pretty complicated. But the main question is, will people be able to teleport? There are some problems here. People are much more complex than one particle because every human consists of trillions of particles. In addition, a quantum teleportation model on a human would look like this. Every particle inside, every atom inside, every molecule of your entire body is measured in the Alps. All this information is then sent to the pyramids of Giza. And they're based on this information. Your double appears and your body in the Alps gets destroyed. Visually, this is teleportation. You disappear in one place and your identical copy materializes in another. But this moment with the destruction of your original self is a little scary, isn't it? Our memories, our reactions to certain events, our thinking patterns, our feelings, our experiences, are all these also inside subatomic particles. If we look at ourselves through the prism of the quantum world, will we see only the physical body? What about our spiritual world? Is it possible to equate it with the particle world, or is it something different? In this case, teleportation with the destruction and appearance of a copy in another place won't work. Yes, another you can teleport to another location, but will it be the real you? And where is the guarantee that after teleportation, some part of you will not be lost? What if you lose a piece of yourself again during further teleportation? I'd say trains and planes look much safer at the moment. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Thanks for watching. Cool.